A quiet beach looks like a place where the land simply ends, but the sand grains beneath your feet are actually moving through a vast, natural production line that stretches across entire continents. If you look closely at these grains, the variety is striking. Mixed in with common, pale quartz are much denser, darker fragments. These are valuable heavy minerals, specifically ilmenite, rutile, and zircon. These specific minerals aren't created by the ocean waves, yet they are found here in massive concentrations along the water's edge. This landscape is the output stage of a geological process that treats mountains as raw material, pulverizing stone to extract the heavy minerals hidden inside. To see how this happens, we have to trace the sand back to its origin, away from the breeze of the coast and into the most violent environment on the planet. The life cycle begins with volcanic eruptions. When liquid magma reaches the surface, it brings a fresh supply of heavy elements up from the Earth's interior. As the lava cools and hardens, it forms solid igneous rock. This is the parent material, where those valuable heavy minerals are locked away inside a dense, stony matrix. Although this rock appears invincible, it is immediately targeted by the atmosphere. This is mechanical weathering. During the day, the sun heats the rock, and at night, it cools rapidly. This constant cycle causes the mineral crystals to expand and contract at different rates, forcing the rock to fracture. Rain and wind then penetrate these cracks. Over time, the stress of the climate reduces massive rock formations into piles of loose, jagged debris. At this stage, mountain ranges are effectively giant stockpiles of pre-sand, waiting for the next step in the process to begin. When it rains, gravity flushes this weathered debris out of the highlands and into small mountain creeks. These creeks feed into major waterways, like the Mahaweli River. At this scale, the river functions as a high-speed geological grinder. For hundreds of miles, rock fragments collide and scrape against the riverbed. This constant friction pulverizes the stones, gradually turning boulders into the fine particles we recognize as sand. The journey reaches a climax when the river discharges this sediment into the ocean, dumping a mix of common quartz and heavy minerals into the surf. Now, the ocean takes over the work of sorting. The continuous energy of the waves acts as a natural sieve. Wave physics naturally sort the sand. Lighter quartz grains stay suspended and wash away with the tide. Denser minerals drop out, settling on the seabed. Lateral currents then push these heavy minerals shoreward, concentrating them in specific beach zones. While the river provides the raw grinding power, the ocean provides the refinement, leaving behind the dark, mineral-rich deposits seen here. The water completes the sorting, but the final placement of these minerals is the work of the wind. Once the mineral sand dries on the shore, coastal winds lift the grains and carry them further inland, away from the reach of the waves. Over centuries, this process stacks the particles into massive dunes. These are some of the most concentrated sources of ilmenite and zircon on the planet. This creates a single, unbroken chain of events. A volcano creates the rock, the river grinds it, the sea sorts it, and the wind deposits it. When you look at a sand dune, you're actually looking at the remains of a mountain that was destroyed to make the beach possible.